Bonjour, je suis Alexandre Sheldon de Prompt et aujourd'hui, on va parler d'intelligence artificielle et de changement climatique. Donc, la COP26 c'est maintenant terminée depuis 2 semaines et vous avez peut-être vu passer dans les nouvelles, il y a eu un rapport important qui a été déposé pendant la COP26 qui faisait état de 48 recommandations pour favoriser la bonne application, les bons usages de l'IA dans la lutte au changement climatique. Et aujourd'hui, on a la chance d'avoir avec nous un des co-auteurs du rapport qui est chercheur à l'Université McGill. Il s'appelle David Rolnick, qui est aussi titulaire d'une chaire IA Canada-CIFAR associée au Mila. Et il est un des cofondateurs et président du groupe Climate Change AI. David, je pense qu'il est récemment arrivé du Vermont, donc on va faire l'entrevue en anglais. Did I get that right, David? Did you recently move to Montreal from Vermont? Did I get that right?
From various places. I did my PhD in Boston, and most recently I was living in Philadelphia.
All right,
I'm from the States.
All right, so welcome to Montreal, and thanks for taking the time to share some of your insights about AI and climate change. So as I quickly mentioned, the report has 48 recommendations, so obviously we won't have the time to go in detail through each and every one of those. But I thought maybe could you start by just giving us like a general sort of understanding of what do you think is the role that AI can play in the fight against climate change?
Absolutely. So there are a lot of ways that AI can be used to help accelerate different forms of climate action. And there are maybe four main themes that you can see here. The first is in distilling large amounts of unstructured data into usable information to help guide policy or other kinds of decisions. So for example, looking at satellite imagery and pinpointing where deforestation is happening or where there are communities at risk of coastal flooding. Or looking through large textual databases to find, say, for example, climate relevant information within corporate financial disclosures, and really taking large amounts of unstructured information and making it usable and actionable. The second theme is in optimizing complicated processes. So reducing the energy needed to heat and cool a building. This is being done a lot across industry, across homes as well. Taking industrial processes and making them more efficient, using less material, using less energy. Then the third theme is in forecasting. So taking time series data and predicting what's going to happen to reduce, for example, to reduce food insecurity by predicting crop yield, or to help balance the electrical grid by forecasting what supply and demand is going to be, especially where renewable energy is often variable sources, and that makes it a more complicated problem to balance the grid. And then the fourth and final theme is in accelerating the modeling and scientific discovery processes. So, for example, helping design better batteries by suggesting new materials that should be experimented on, not replacing experiments, but augmenting the experimental process to make the iteration process faster, or by help speeding up physics-based models, which are sometimes very time-intensive to run. Having approximations for those can be really useful.
All right. And one thing that you mentioned very early on in the report and that I found very interesting coming from AI researchers and engineers is that you're sort of wary of what you call Techno Solutionism. So could you tell us a little bit about that?
Yeah, well, coming from the AI community, it's very easy to our community is very fond of thinking that we have these magical tools that are going to save the world, and AI can be a useful tool. It can be used to do a lot of things, make the world better, make the world worse. But fundamentally, the most important thing in this area is humility, recognizing that AI is not always relevant for solving problems. It's not a silver bullet. It's not going to magically solve climate change. Where it is relevant, it is only one piece of the puzzle. And really, to make AI be most impactful, it's necessary fundamentally to listen to what people need and work very closely with them. Because this is not a situation of AI coming in, saving the day. You don't have to listen to the people actually doing chemistry or climate science or agriculture or forestry. You have to listen to those people, and you have to be solving the problems, the bottlenecks that actually exist in those areas. Sometimes AI is relevant, sometimes AI isn't relevant. There are a lot of considerations you need to bear in mind to make sure you're building something that will actually be used and actually be impactful and have the right kind of impact. Also, sometimes remembering that the most impactful applications are not necessarily the really flashy ones. Something like optimizing freight routing, making sure that trains run on time. Maybe it's not flashy, but it could be really impactful. Also, really successful from a corporate point of view. I mean, many of these things obviously are well aligned with corporate incentives. Some of them aren't. But yeah, fundamentally, Humility and thinking about what it is that the people want, not throwing flashy algorithms at everything and thinking that that's gonna solve all of our problems.
Right. Before we get to the actual recommendations, just one last point on like maybe your general approach that you took, because you also raise an important question in the report, which is what do we do with AI applications when they are used in high emitting sectors, high emitting industrial sectors? So what do we do, for example, with AI used in the mining and the oil and gas sector?
Yeah, so I mean, one should distinguish between AI applications which are being used in high emitting sectors where that's actually helping to facilitate the emission. So, for example, AI is being used in the fossil fuel industry to do various things. Among them is to help oil and gas exploration and extraction, which is just directly increasing the amount of fossil fuels which are being taken out of the ground and lowering the price of fossil fuels relative to other sources of energy. And that is pretty clearly making climate change worse. As a sense of how much this is, how the scale of this. It's been estimated that AI and advanced analytics are going to make the fossil fuel industry about $500 billion more profit by 2025. Obviously, that's coming from a lot of different areas, but there's really a lot of AI being used in lots of different sectors, and some of these are beneficial to climate action, and some of these are assuredly detrimental. Some more subtle applications are potentially social media recommender systems, advertising systems that are designed to boost consumption, and they're almost certainly increasing the amount of global consumption of various resources. So you're really thinking in those terms of what the additional effect of AI is. Sometimes you can use AI to reduce the emissions of a high emitting sector, but in many of these cases, AI is being used to actually increase the emissions essentially. And so really thinking about that. Oftentimes it's also the decision of the technologists how a new technology is being developed. So, for example, self-driving cars, which are a great technology from various perspectives. Arguably, safety is a very useful reason why one might be interested in self-driving cars, but from a climate perspective, if they are increasing lowering the barrier to driving, increasing the amount that people drive, that could lead to increased use of gas, like quite significantly, and could end up making climate change significantly worse. But if we're, on the other hand, designing autonomous driving systems so that they're used more in public transportation or in vehicle sharing options, that could actually be making climate change better. So it's really oftentimes up to us how we're using a new technology. It's not inevitable. We get to decide how